Quantum computing seeks to take advantage of the quantum effects. When you think of a classical computer, right, we have these zeros and ones, which we call bits. But in quantum computing, we actually have everything between a 0 and a 1. And that allow us to apply certain tricks that make quantum computing much, much more powerful.
At the smallest scales possible, nature behaves by very different rules to how you and I know and experience it. Those rules of quantum mechanics means that we can gradually build something that looks like a logic 1 or 0 and use that to execute algorithms, which we can use to solve problems. The experiments time and time again proved that these effects, really bizarre though they may seem, hold up. I think it's pretty safe to say that we actually don't know what we're going to do with quantum computers once we have them. That said, there are two very proven and useful algorithms that we know that quantum computers can solve.
One of those algorithms that is potentially very, very powerful and will mean that quantum computers are really important is called Shor's algorithm, which we use to factor really large integers. All of our encryption is secure because factoring large numbers is really hard. And if we have a quantum computer that's powerful enough to actually execute this algorithm, that would mean trouble for anything that's based on RSA encryption.
The other one of those two algorithms is called Grover's algorithm. And Grover's algorithm is about finding one element of a list, one number in a big unstructured list of numbers. The current people who are building prototypes are building quantum computers that will be warehouses in size with dedicated cryogenics plants. I spend my day shining lasers at small crystals to try and store information in them to build the next generation of the internet.
I'm studying quantum error correction to correct the errors in really unstable quantum systems so that we can perform reliable calculations and store information reliably.
We're surrounded by lasers, cryogenic systems, single photon detectors, oscilloscopes, all sorts of crazy kit. We have people who are working on the mathematical formalism, the frameworks, as well as people who are in the lab, spanner in hand, making it happen.